Hi guys, welcome to my channel. In this video we are going to solve the questions about the water resources engineering, and the question will be a concrete gravity dam. Now you can see on the screen. And now let's solve the question. But before we solve the question, if you like these videos, if you want to see more of the videos, please subscribe and share with your friends. So now let's pass the question. First, I'm going to read the question for you. Consider the gravity dam shown in the figure. Determine the bottom width of the dam such that a triangular base pressure develops at foundation. Ignore ice, silt, and earthquake forces, and take the stress value is 30 megapascal and the foundation stress is 90 megapascal, and the phi is equal to 1, and specific weights of water and the concrete are both of them are 10 kilonewton meter cubic and 24 kilonewton meter cubic respectively. So now let's solve it. First, I'm going to calculate the forces and the moment arms and the moment, then we are going to multiply them one by one. So first, I'm going to show you that how the forces that's going to act on this dam. This is the point toe. Okay, this is the point toe, and we are going to have an horizontal hydrostatic force as FH here, and I'm going to divide this block to 2, as one is W1 and this one is W2. They are going to look down, and we have also here as FU, okay, uplift force. So now we have just these four forces because these are ignored. Okay, so now let's calculate it. Forces, and for W1, look at it, this is 10 meter, this is 10, and this is B minus 10, right? This length from here to that point. So now I guess we have all dimensions. Let's write the calculations. And for W1, it's going to be, for W1, look at here, this one, 10 meter multiplied 100 meter, the height of the block multiplied 24, and this is going to be 24,000 kilonewton meter as the force. Okay, so and we have W2. Let's check for W2. For W2, look at here, it's a triangular, right? So it's going to be 0.5 multiplied 90 plus y90. Look at here, this is 100. Okay, from that point to here, 100 minus 10, it's going to be 90. This height. So 90 multiplied B minus 10, the bottom width of block, and multiplied 24, the unit weight of the concrete. So it's going to be 1080 B minus 10. And so for FH, horizontal force, horizontal hydrostatic force is going to be 0.5. Look at here, this is a triangular shape. 0.5 multiplied 100 square, 100 square multiplied 10, unit weight of the water, and this is going to be 50,000, okay, kilonewton meter, and this is also kilonewton meter. And we have also uplift force, if you remember. So for uplift force, it's going to 0.5 multiplied, look at here, this one, okay, 0.5 multiplied 10 multiplied 100 and multiplied the base with it. So what is base with it? Base with it is B. We don't know. But this one, look at here. I'm going to show you something. This one is 0.5. Why it is 0.5? I'm going to show you that. At uplift force, we have formulation. Okay? Uplift force formulation is this one. Look at here. Is phi over 2 multiplied unit weight of the water and multiplied the hydrostatic height and multiplied B. Okay, so this phi is this one. I'm gonna show you 1 second. This one, okay, and this one 1 over 2 is 0.5 multiplied 10 and multiplied 100 multiplied B. So this is going to be 500 B kilonewton meter as the uplift force. Okay, so now we have forces. Let's specify the moment arms, and then we're going to calculate the moments. Okay, so for the moment arms for W1, okay, for W1 moment arm, it's going to be the midpoint of this block is 5. Okay, 5 from here, 5 from here. So it's going to be, if this whole length is b, the moment arm respect to point O is going to be b minus 5, right? B minus 5. I guess you understand how I'm calculating that. So for W2, it's going to look at here. W2 is here, is a triangular. If you remember that the center of gravity for a triangle is the 2/3 of the triangular. So this is b minus 10. Look at here, this point, this length. B minus 10. We are going to divide it 3 and multiply 2. So for W2, it's going to be b minus 10 or divided 3 multiply 2. Okay, we got it. Let's do it for the horizontal force. For horizontal force, look at here. This is 100, right? The height of what is 100? So I'm going to take, and it is a triangular. We assume that it's triangular, so it's going to be 2/3 of that. So 100 multiplied, so it's going to be like this. Multiply 2 over 3, and this is going to be 32.34. So, and these are the meter, okay? So now let's do it for the uplift force. For uplift force, we are going to have, look at here, this is a triangular, this shape, okay? The shape is triangular, so it's going to be 2/3 of this shape, B, okay? 2/3 of B. So let's write it here, 2/3 of B. One second. Okay, this one for uplift force. So now let's multiply them, and then we are going to obtain the moments. I'm going to write the moments here. Moments, okay. And for first one, for first force, for W1, we are going to multiply this force to its own moment arm, okay? So this is going to be 24,000 B and minus 120,000. Okay, so now let's do it for the W2. And this is going to be 720 multiplied b minus 10 squared. One second, I made a mistake. Yeah, it's going to be like that. This is better. So, and now for horizontal force, and this is going to be 1,667,000 as the moment. Okay, so now let's see for the last one, uplift force, and this is going to be 333.34 b squared kilonewton meter as the moment. So now we calculated moment. Let's specify that which one is overturning and which one is resisting. Okay, so look at here. This side is overturning, and the clockwise, counterclockwise direction is resisting moment. Okay, so the F horizontal is creating a moment at the clockwise direction, so it is overturning moment, and uplift force also creating a moment at the clockwise direction. So we are going to have these two forces, okay, these two forces as overturning, and these two forces are resisting moment. So now let's write them down. Overturning, what I told you, that FH and FU, okay? So this is going to be total M0 and 166,700 plus 333.34 B squared, okay? And for the resisting, total MR is equal to, and I'm going to write it down as open part, okay? So 24,000 B minus 120,000 plus 720 B squared. I open this parenthesis. Okay, I open this parenthesis, and now minus 14,400B and plus 72,000. Now here, this is the moment resisting. Okay, so now let's write a total vertical force. So net vertical force. Okay, I confused about it. So what is the vertical forces that we have? Let's check. We just have a W1 and W2, the self weight of the dam, and also we have an uplift force. So now I'm just going to write them down. W1 and W2 at the positive side, and uplift force is the negative side. Okay, so, and this is going to be 24,000 plus 1080B minus 10,800 minus 500B, and this is equal to 580B plus 13,200. Yeah, 200. So now I got the net vertical force. Let's get the net moment. So for the net moment, one second, net moment is going to be equal to M resisting minus M overturning, and this is going to be 386.66 B square. Okay, and plus 9,600 B and minus 1,715,000. Okay, so now we have it. So now I'm going to show you a formulation of the net vertical force that the variable is going to be applied. Okay, net moments over net vertical force. Okay, the formulation is like that. So how it's going to be calculated? We are going to divide the net moments over the net vertical force, but before that, we know that something like this. If you remember, the eccentricity must be at the B over 6. Okay, so look at here. This is the midpoint. Okay, this is the B over 2, and this is the B over 2. Okay, so now eccentricity from that point, the center of the base at the B over 6. For example, this is B over 6. Okay, and this part is B over 3, if you remember. So now we have it. Let's do it. This has to be equal to B over 3. Okay, so I'm going to write the equation. 386.66 square, so B square, plus 9,600B and minus 1,715,000 over net vertical force. What was the net vertical force? 580B plus 13200. So now this is the calculation, and when we multiplied this with the cross, okay, so I'm going to obtain a formula here, sorry, an equation here. One second. I'm going to obtain an equation 98 B square and plus 1566 B minus 5145000 equal to 0. Okay, so when I solve this quadratic equation due to discrimination, if you remember that delta was equal to B square minus 4AC, and so minus B plus square root of delta over 2A. This is the root of that quadratic equation, and when I solve that, I'm going to obtain as B is equal to 81.74 meter. Okay, when you solve this equation, due to the discriminant formula, and you're going to obtain as the root of that, so that means the B is 81.74 meter. Okay, so now the question is solved. If you like this videos, if you want to see more of the videos, please subscribe and share with your friends. Anything I did wrong, please warn me. I'm going to try to fix it. See you for the next question.